have David Leadbeater, who's going to be talking to us about developers, the weakest link in the supply chain. Thank you, David.
Thank you. Yeah, so hi, I'm David. I work for G Research Open Source, and I'm talking about the supply chain. So what is the supply chain? Well, this was a bit of a massive problem in 2021 when the Ever Given got a bit stuck in the Suez Canal. And obviously the impact on the physical supply chain made the news. More recently, some supply chain attacks on things like NPM have made the news as well. But this one is possibly more impactful across the global economy. So here's an iPod Nano from 2006, and on the back, Apple put, designed by Apple in California, assembled in China. Now, legally, they probably have to put where it's made, but they decide for branding reasons to say, designed in California. And why do they do that? Well, you know, they've got a big office in California, they're a Californian company, but also this means that they're writing the software and making the hardware designs in California. So more of that goes into that iPod is not just the hardware, but the software inside it. And so that brings us to the software supply chain. So I'll distract you with some chocolate for a minute. Why? Well, if you look at the back of it, it's got some ingredients on it. And, you know, the ingredients say things like full cream milk, sugar, cocoa butter, and so on. But also just below that, it says may contain wheat, gluten, peanuts, apparently. So that's because they share the tools that they use, the production line. They share it with other chocolate that they make. And so there's the chance of cross-contamination. Now, for bits and bytes, we don't quite have the problem of cross-contamination, but maybe we nearly do. Like, some of the things that can happen are sort of unexpected crossovers between technologies. So that's what I'm talking about. So let's have a look at some software ecosystems. So if you're writing Go code, you have a go.mod that specifies what your dependencies are. In Rust, Cargo, package.json for Node.js and some other JavaScript ecosystem stuff. Python, you have pyproject.toml, although if you're familiar with Python, you have various other options as well. And that's kind of a problem as well. There's not a standard way of specifying what your dependencies are. Which doesn't matter when you're building the software, but when you're analyzing software for security problems, that begins to matter. So something recently has been developed called software bills of materials, or SBOMs, and there are various formats for those. So one of the formats is the SPDX format. There's also CycloneDX, and basically they say what your dependencies are. And so they're a standard way of extracting the dependencies from the ecosystem-specific files and other places that data is stored and turning it into something that can be analyzed by a system. But that doesn't capture things like tooling. So there's a lot of things that are up to what the developer does, and that's where we sort of come to this talk. I'm not really going to talk more about SBOMs because there's a lot of things that SBOMs can do, and that could be a whole other talk. But they're an interesting area if you haven't looked into them, particularly for sort of open source security and keeping track of your dependencies. So let's go on to some Go code. So I've mentioned dependencies. And when you import some packages in Go, this is the syntax you use. You import strings. So strings is part of the standard library. That's pretty normal. Okay, also import something off GitHub. So how does that work? Well, you just put the path there and it magically imports it. But you can also put something like git.example.com, and then that will also work, and Go will go and check out the code from that remote system. So how that actually works underneath is if you start looking at this, when Go sees that URL, it expands it into an HTTPS URL, and then in the actual source code of that URL, there's a Go import meta tag, and that tag explains that for the package on the left-hand side, there's a particular version control repository type, and there's a particular location that is to be found at. And if you go and read the docs on for modules in Go, it explains that if the URL doesn't have a scheme, then it will fall back and find the attempt to find where the code is by trying various options. And so it also mentions that there's a module path is matched with the Go insecure environment variable, then it will use other protocols that are not secure, like HTTPS and Git. So that brings us to the first vulnerability. There was a bug where basically Go just didn't do what was documented. So if you had, in this example, the last one where you've got foo.git, if that particular package path was used, it would attempt to check it out as it should do over HTTPS and then attempt to use Git and SSH combined. But if those failed, it would fall back to HTTP. And so what's the attack there? Well, the pretty obvious one is some kind of man-in-the-middle attack. An attacker can't change the HTTPS certificate or get that, but they can, via a downgrade attack, force the client to not be able to connect over SSH or HTTPS and then go far back to HTTP. So I found that in 2023. And it's actually not a very serious vulnerability because Go has various mitigations here. When you add a package to a Go module, it basically says, what's the checksum of this package? I'll download that, and then it saves that in a separate file called go.sum, which means if you have already checked out a particular package, it can't change, and it essentially is immutable. So it also needed a particular environment variable set. So Go has this Google service that it uses automatically called the Go proxy, which is a basically cached repository of module source code. Obviously, you can't attack that, and it's always over HTTPS. And it also has something called the GoSum database, where as well as the local file with GoSum, there's a central repository of what all the expected checksums are for particular module versions. So overall, it was a very low severity CVE, but it does show that in very unexpected places, there are ways of attacking the supply chain. And the amusing thing about this is, imagine a developer at a conference or somewhere on open Wi-Fi, it would be possible to attack them through this kind of mechanism. It's a bit of a esoteric case, but there are potential exploits there. So Go may be a polarizing language, many opinions, but it is well designed. There's defense in depth here. So although there was a vulnerability where it attempted to use something that was insecure, it had multiple checksums on top of that, which meant the impact was quite limited. And just to sort of mention a bit further, so in a go.mod file, you have something like this, where it declares the Go version it uses. And Go now will automatically download the correct version of the toolchain that has been used for a particular module. So the neat thing there, going back to tooling, is if there was a vulnerability, you essentially upgrade the toolchain in your go.mod, and then it will automatically download a new version of Go. Obviously, the problem there is that you do actually have to keep that up to date, and so it's not perfect, but it is a good way that it captures the versions of things that were used, which, like I said, for SBOMs, that might not always be captured. The build time stuff sometimes isn't captured in SBOMs, and there's some other things in that space. So moving on now. So OpenSSH, I mentioned already that Git and SSH are often combined, but we'll just look at SSH itself for now. So here, if I SSH to example.com, it asks me for my username and password. Fine, login, example, good. That's just how SSH works. Enter DNS. So what happens if we do this? Well, that's silly. Why would that work? Name or server's not known. Okay, let's try that on a different system. Oh, that's strange. What? Let's try that on yet another system. And so on this system, it actually says the authenticity of host can't be established. That's a bit strange. Okay, so what's happening here? So this host does resolve. So this isn't my test at home. There's a wildcard DNS entry, so anything before wild works. So fine. What's actually happening here? So on the system where it said host key verification failed, it says invalid host name. So there's some checking in SSH that checks whether the host name is valid. So the thing here is that what's valid in DNS is a larger subset of characters than what is valid for a host name. So you can have entries in DNS that aren't a host name. And that's fine, because if you've used things like SRV records where they start with an underscore, technically an underscore is not valid in host names. So this is kind of expected and used, although there are lots of edge cases here, as you can see. So this was a bug in OpenSSH that I found, and this was back in 2023 again. And basically, there's a long description there. But basically, if we go back to the host name, it's got a comma in it. Now, if you're familiar with how SSH records known hosts, so it uses the time of first use check. When you first SSH to a system, it asks you this thing where it says the authenticity can't be established. There's no certificate CA there. It just asks you to yourself verify that fingerprint. There are other things you can do, like using DNS. There's more to be said there, but I haven't got time for that in this talk. But basically, when you then say yes, it writes that to a file. And so what would happen is it would write the comma to the file along with a wildcard before it, which meant that what the user had just accepted became accepted for any remote host. And so if you somehow trick the user into accepting a weird thing with a comma in it, that's a bit strange. Maybe a user or developer won't do that. But I did find one weird configuration where SSH used DNS to canonicalize host names, and it would be a bit of a strange configuration, but there would be a case where someone could man-in-the-middle DNS, which obviously in most cases is not authenticated, and could essentially trick the user into connecting to a different host, and it would bypass the time of first use check in SSH. So yeah, configuration dependent. This actually gets more fun though. So what happens if we put an ANSI escape character in there, and it turns it red? Well, it turns out at one point SSH actually outputted that to your screen, and so obviously this doesn't really matter. I'm not going to accept that. But what about if we put the entire host name to be what the SSH will print? So it says your authenticity of host github.com can't be established. And if you look closely, this starts to look a bit fishy because it lowercased everything. So it's not a really great attack. But I've replaced the SSH time of first use banner with something else via injecting it through DNS. It sort of could potentially confuse someone, but as I said, it's all lowercase. I didn't even fix like some of the weird cases there, because there's also a length limit in DNS, so it's really hard to just about squeeze in the thing here. But anyway, it does sort of work. But it's not, it gets down to, like, with the NPM attacks recently, developers were phished by accidentally replying to an email or clicking a link in an email that came from npm.js.help rather than .org. Like, maybe this could phish someone, but, well, first of all, they're not going to be SSHing directly to a host name like that because, well, probably, I mean, if they're doing that, we've probably lost at that point. So anyway, there was another fix for this that I realized later on that actually previously wildcards were disallowed. The comma wasn't. So if you notice in this variant, it's github.com, comma, and then a /b, which is a backspace, which hides when we look at the output, it hides the comma there. So if you accept this, it replaces an accepted SSH key for github.com with something that you have access to because it's your host that it's actually trying to connect to through wildcard DNS. So anyway, and you could maybe come up with something a bit like this, where it's like opt equals example.com, make that look believable, sort of, maybe. So how do we fix this? So there's obviously the SSH side, but the other thing is, like I said, what's valid in host names is different to what's valid in DNS. And this was a commit to OpenBSD. OpenBSD restricted the characters that their resolver allowed resolving, so that you can't put a comma there, which fixes this problem at another level, and good defense in depth. So actually, this can't happen on glibc. It can happen on Muzzle. So a bunch of those demos I was just doing just then were using Alpine because it uses Muzzle. OpenBSD has now fixed this. macOS, I've reported several issues to Mac and Apple, and they're not that interested in fixing things unless there's an obvious RCE in it. So macOS hasn't been locked down. Windows already does filter this and has for a very long time, although there's some different edge cases there I won't go into. So let's move on to Git. So I mentioned SSH combined with Git. So this was a vulnerability that someone else found back in 2023. Credit to Vinci. It's cut off his name at the top of this, sorry. So anyway, this was using proxy command in SSH, so it's a very particular configuration, and that particular configuration meant that when you connected to a particular host, the proxy command would allow escape character injection and shell meta character injection. And anyway, so there's a proof of concept here. So the idea here is when you git clone a particular repository, with this vulnerable SSH config, it uses submodules. And so submodules are where you have a Git repository that refers to another Git repository. And probably the best way to show that is with a output of GitHub. This is just a small screenshot of a bit of GitHub. And you'll see in this repository it's got CVEs at some commit ID. And so one repository refers to another repository. So the CVE we're talking about here was basically having the SSH URL was backtick's open calculator. And so as you would expect, if you configure it like this, and then you just clone his test repository, well, that happens. So again, this is very configuration dependent. The user would actually have to have this very particular, this very particular SSH config, which is, possible, but so anyway, Git has interesting attack surface. So this is an example of another bit of attack surface in Git. So Git has some other URL schemes. I've mentioned SSH and HTTPS. It also has this ext URL scheme, which basically just means run this command. Fine, okay. It doesn't let you do that off the command line. You actually, by default, it's turned off. You have to configure it. So how does Git work? So Git has this nice feature where if you can't type very well because, you're like me and whatever. Anyway, so you can't type clone. You can set this config option called help autocorrect, and it helpfully autocorrects you. And so it says, warning, you called a command called clone. Did you mean clone? And helpfully runs it for you. So if we git trace a clone, we can see that underneath Git runs a command called git remote HTTPS to do the clone. Okay, fine. So what if we just put a dash there? Yeah, it turns out that works. So it continues under the assumption that you meant remote X. No, you hadn't even typed remote -X. It just added that for you. So fine. So yeah, that does what you'd expect. But before you get excited, this is not actually a real problem. You can't use ext from submodules at all. It's another level of things that blocks this particular attack. So you'd have to somehow engineer the user into actually running that command, which is a bit strange. And at the point you've got code execution on the user, then they could have done something else. So that's an example of what could be possible, but that's not actually a vulnerability in itself. What has happened here? Oh, that's exciting. We haven't full screen that. All right. Oh, sorry about this. Just Linux problems. Oh, there we go. Okay, so I use this on my blog post about what's coming up, and I quite enjoy, vintage technology. So this on the side of it is a typewriter. On the side of it, it has a carriage return lever. Now, carriage return is an interesting character that we have as a legacy of ASCII. And if you've transferred files between DOS and Linux, you probably come across that you have a CRLF ending, and then you, depending on what you're looking at, you see a bunch of caret M's or something else appear that you don't expect to be there, and you need to convert the file or whatever. So this vulnerability used that very character. So how does it work? So Git submodules are, as I've said, sort of the vector for a bunch of these things. In this case, I just try to add a submodule that when you do add, you can give an optional name for it on the end. So I'm trying to call it /r, which is carriage return in C-style escaping. And then it fails. It says not a Git repository. But notice that it seems to have stripped the last character there, which is interesting. but it hasn't in the middle because it's got this question mark here. So that's a bit strange. So what happened here? Well, if I instead add the submodule and just call it foo directly, and then I move it, so I use git mv, in Git modules then you'll notice that it says path equals foo and control M. Like I said, that's what the code return looks like in depending how you output it. So what happens here? So when Git goes to parse that submodules file, because it sees a DOS line ending, it strips it. And so when we run git status after doing that, we see fatal can't change directory to the thing ending in foo, no such file or directory. Well, that's interesting. So we've sort of confused Git. It thinks the file is called one thing, but it actually has another name. So what if we make foo exist? So in particular, what if we turn foo into a symlink to the .git directory, which is where Git stores all its important stuff, and then we create a hook in there called post checkout and chmod plus exit, because Git wants to check it's a shell script. Anyway, so if we do that, we clone a repository. So I'm using GitHub Desktop to clone it here. So this works in various contexts, but definitely for GitHub Desktop. Cloned it. Okay, cloned. Oh, interesting. So yeah, basically this was an RCE against Git itself, which worked both on client-side things. So if you cloned on the command line, you include ---- recursive, then you would get a bad repository could do bad things. Also, through GitHub Desktop by default turns on the recursive clone option. There's a URL at the bottom there. Sorry, that's not very big, to the full write-up, but it's just on my website, so I'll have a URL to that at the end. There are other places that this could be used, though. So GitHub Actions, for example, has an ability to check out Git repositories. That's what you'd expect it to do. It underneath just uses Git to do this. So you do that with something like this. And so if you did have with submodules true, then potentially if someone were to open a PR with a bad submodule, it would run that code. But that's actually fine because you expect that code that is run through GitHub Actions by default runs on that user's forked repository. So they hopefully don't have any extra permissions there. So that's not so bad. But there's this lovely feature that GitHub Actions has called pull request target. And if you were to find something that uses pull request target to check out the submodule from basically the other branch, so it runs in the pull request target runs in the non-forked repository against, if you specify it, against the forked repository. It's generally a really bad idea, but it turns out people do use it a bunch. So here's you can code search for this quite easily. I haven't actually checked whether any of these are vulnerable to this. And GitHub, because I reported this through GitHub, GitHub actually had a new version of Git installed on GitHub Actions basically at the same time it's released. So there wasn't really any risk here, although, bad actor had discovered this, then yes, maybe this could have been used as yet another supply chain attack against GitHub Actions, as well as a client-side attack. And, as we saw in the previous talk, people like North Korea are trying to get developers to do evil things. So, yeah, so GitHub Actions is a bit scary. That particular image was from Yossarian, who I'm probably saying wrong, but he also has a open source project called Zizmor, which audits GitHub Actions. And one of the things it does is it say, you're using pull request target, don't do that. It doesn't actually have any, it doesn't see why you're using pull request target, it just says no. So yeah, that if you are using GitHub Actions, that's something worth looking out for that. So did I get a juicy bug bounty from GitHub? No. So little rant here. GitHub said, yeah, well, this is in an open source dependency of ours, so we're not giving you a bug bounty for a GitHub Desktop RCE, even though I proved that, it was usable from there, which is fair. But, it's like a bit of a special dependency when your entire company is named after it. But fine. I don't have time to fully rant about how open source and bug bounties intersect, but there are many cases where some of these vulnerabilities I've reported to companies, and they're like, yeah, that's not very serious. And they're like, well, yeah, but it's an open source project. Can I just patch it? And in one case, some company just said, actually, well, no, because you've agreed to the bug bounty terms, so now you can't reveal this. So it's like, yeah, I could just write a PR anyway. So there are multiple cases where I mostly don't bother to submit things to bug bounties. I naively thought GitHub might be more reasonable about it when it was Git itself. But anyway, that I could rant more about that, and I don't have time. Is this a new thing? So I'm sort of, in summary, this was the Turing Award lecture from Ken Thompson in 1984. That was where he backdoored a C compiler, right? The developers have both been looking at security, breaking security, and not understanding security for as long as developers have been developing software. I sort of identify in between a developer and a security engineer. So I think there are many things that can be done better. Improving the tooling, it's a bit strange to fish someone through an SSH link, but it's possible. So yeah, anyway. In summary, I've only covered Git and SSH here. There's many other ways developers can be attacked. I mentioned GitHub Actions a bit as well. Editors are interesting, particularly when you combine that editor with AI through an MCP or other things. Yeah, I think XZ changed mindsets as well. Like, how much do you trust the developers when a developer might turn up to an open source project and start doing scary things? So this is why, vulnerability in Git like this is a bit scary, because, well, actually, if you just pull the latest project and some bad developer has put something bad in there and attacking the other developer, like there's all sorts of scary things. So yeah, thank you.